Geometry. We are still working on volume. The only thing that has changed is we are now in a new section and we will be talking about pyramids and cones instead of cylinders and prisms. So our essential question stays very similar. Can I find the volume of, and today we're going to be talking about pyramids and cones. The transfer from prisms and cylinders to pyramids and cones is a lot easier for volume. So surface area, you could find similarities. I mean, there was still perimeters, big P's. There was still, instead of two bases, there was one base. But besides that, there wasn't a lot of similarities. The volume is way easier to find the similarities between, for example, a prism and a pyramid. Instead of the area of the base times the height, it's just 1/3 of the area of the base times the height. So these are very, very, very similar. Same thing with cylinder and cone. Instead of pi r squared h, it's 1/3 pi r squared h. So I think it's a lot less work, especially when we're also talking about composite figures again. It'll be easier to add those things up. So I'm going to write down our formulas. We have pyramids and we have cones. I don't know what that was. Here we go. Cones. The formula for a pyramid is, the formula for the volume of a pyramid is 1/3 the area of the base times the height, whereas the cone is 1/3 pi r squared times the height. And I didn't even need to look at my formula for that. I just looked at my formula for the pyramids, and that's the area of the base. And guess what? If it's a cone, the base is a circle. So that's the area of the base. They're the exact same formula. We just make our cones maybe a little bit easier. So instead of writing 1/3 base times height every single time, we're saying, hey, if we know the base is a circle, that's what our formula is going to be. So there actually isn't any difference. This is just catered to a circle. We're going to do 2 examples right away. And then on our next volume day, we'll do a little bit more complicated problems. So we're going to start with an example for a square pyramid. So I'm going to draw my triangle. The base is a square. I sometimes think it's easier to kind of draw your base there. That doesn't look like a square, but it's going to be a square because I'm saying it's a square. We're just going to pretend that that is a great, perfect, wonderful pyramid. So what might make a pyramid different for volume than for surface area is I do not need the slant height for the pyramid. I instead need the height. So when I was looking for the slant height, I could find I might have been given the height and I could find the slant height, and same thing here. I might give you the slant height and you have to go back and find the height. But we're going to stick with stuff that's already all given to us. I said this is a square and it only works with these regular pyramids. The bases have to be regular shapes. And then the height goes from the very top directly down to a 90-degree angle. Man, this is a horrible drawing. Whatever. Directly down, and that is 6. So we're going to call those inches. I forgot to do that. Okay, so I actually have everything I need. Let's look and see what the volume is. The volume is 1/3 times the base times the height. Well, in this case, the height is 6 because it's from the vertex, the highest vertex of the pyramid, directly down at a 90-degree angle. That's your height. And then I'll use some colors. The area of the base, well, this is a square, so that actually ends up being a lot easier for us, and that is 16. 4 times 4 if you want to remind yourself of that, where I got that 16 from. And at that point, you plug it in your calculator. You can, if you type in 0.33, you're going to get a rounded answer. It's not going to give you exactly 32, which is the correct answer. So make sure that you're using 1/3 in parentheses, like when you're typing it in your calculator, type it in like that. Use the fraction button on your calculator, or if you do not have a calculator, if you only have your phone or just a plus or minus calculator, type in 0.333333 and type it in a few times, and it should round it for you automatically. But that is 32 inches cubed because it is volume, it's not squared. Okay, let's do a cone. Again, you could have paused the video if you needed some time to draw. All right, cones are a little bit easier to draw. Start with a triangle. Give yourself a circular base. Okay, that looks a lot better. I've redeemed myself a little bit. Okay, at this point, you only need your radius, right? Because my volume is 1/3 pi r squared h, or the area of the base, which happens to be a circle, so that's pi r squared. I need my radius. My radius is given to me. It's 16 centimeters. But I need the height. But I'm not going to give you the height. I'm giving you the slant height, which is 34 centimeters. So some of this is given to me, some of it is not, and we need to figure out how to get what's not given to me. My radius is at 16, but my height is not. But I do have a very nice 90-degree triangle that I can do some work. I can say, well, if this is 16 and that's 34, what's that leg? Normally I'd say, okay, just do this in your calculator and we'd check it in class, but I want to make sure that you are setting this up correctly. 34 and 16 are not both legs. 34 is the hypotenuse, so it needs to be that C value in the Pythagorean theorem. Solve that. Do we need to do? The height is technically equal to, or that h, or x, or whatever you want to call it. The height is 30 centimeters. So we're going to plug that in. 30 centimeters. Plug that all in your calculator. 1/3, use parentheses pi. Don't use 3.14. Try and use the pi button if you have it. If you don't have it, just search online what the extra digits of pi are. So type in 3.1415926 and your calculator should round it for you pretty nicely. But either way, your answer should be 8,042.5 centimeters cubed.